In this video I will show you how to use Keras in Python to classify if images correspond to a floor that is tidy or non-tidy. So these are a lot of pictures that I have here. It's full of toys when it's non-tidy, and if not, it looks quite good. There is a previous video that you can check here where I explain the specifics about this, and I did one convolutional neural network in Keras, and it worked quite well. In this case, I will extend that previous video, and I will be doing 4 experiments. I will be doing 4 different models. I will be running them sequentially, and I want to test different configurations. My goal here is to achieve or to get to a model that is around 90% accuracy or more, but that uses less parameters. The problem that I had before is that my model was just too big, too many parameters, it was too slow to train. Ideally I would like something small that trains quickly. For that I will be using Prython as my IDE. You can download Prython from this website. It is available for Windows. And you need to also download this image_processing floor classification reducing model from my GitHub repo that you can check here. Also remember to download the images, and you need to put them somewhere. Why I'm using Prython? So for 2 reasons. First, it allows me to separate my Python code into panels as I have in here. And secondly, it allows me to run experiments that I can track and see on the same screen. So essentially the way this works is that we have panels. Inside each panel we can just put our Python or our code, so we can just click in there. We have 3 running modes that I will explain in a minute, and then we have an out and in connection. So in the in connection is essentially like an input. So whatever we define in our previous panel that's connected to the in will be fed in here. And whatever is connected to out will be able to access the variables defined here. So for example, x that you can see here, I am defining it here, but in this panel I will be able to access x. You can see x is here. I am not defining x anywhere other than in here. So this x that I defined, I will be able to work with it. The 3 running modes that I have here, so this runs only this panel, which is not what I want. This runs up to here, meaning that this runs whatever is connected to in, so everything that's feeding variables into this and this panel, and this runs everything that's connected to out, which is exactly what I want. I want to press in here and then run each one of these models. One extra thing that I did here before explaining the different models that I have is that I added these windows. You can add these windows by clicking in here, copy output to new window. That allows you to copy the output that you will be producing in real time into a new window. You can edit the name here, so you can put. And this is useful for many reasons, but one of the reasons is that you can copy a lot of different models and put them all next to each other, and because the windows are small, you can kind of see all the outputs. So anyway, what I did here was to copy the 4 models that I have, and I put them here because I will be comparing that. The models are essentially convolutional neural networks. So here I'm using this is my standard model. This is the same model I had in my previous video. This is 2 strides. Standard convolution, not too complicated. Probably the interesting bit here is the callback. I am using a callback here to print a progress into the output. However, the progress, whenever it has this structure, it is automatically parsed by Prython, and it creates this progress bar that you can see here that you will be uploading every time an epoch finishes. Yeah, I just define a class with a callback, and then that's really it. Prython will automatically detect this is a Keras model, and it will create a plot in real time showing how the training goes. So that would be pretty cool. It would be the equivalent of doing TensorBoard in multiple models in the same screen, which is pretty awesome. So that's my initial model. Then the other model that I want to try is a strides equal to 2 plus extra convolutions. So my idea is that by adding some extra convolutions, I will reduce the number of parameters. We'll see. Then I want to test strides 8.8, so ideally this will reduce the number of parameters, because more strides means more spacing in the convolution and means less size. And finally, strides equals to 8 plus extra convolution. So I would expect this model to be quite small. It should be running much quicker than the other ones. And then, as I said before, everything will be dumped into there. I will run everything here, run below, and let's get this started. So the first thing you can see, the panel started, there's a message there, and then I can see scheduled, next to run, started, scheduled. So this has been executed. Now this is running. This is a monster model. It says 7 million parameters, just huge, and that's the reason I want to reuse it, just too big. Bear in mind also that Prython shows all the Numpy elements that were detected when a panel finished. So essentially what's going on is that when this finishes, when this print statement runs, Prython scans all the Numpy arrays and prints the arrays with the dimension. So it's pretty cool. In my case, you can see that the typical image is 500 by 375. It's got 3 channels, so red, green, and blue. And then my modeling dataset, or my modeling matrix, to be more precise, has 412 images of this size. And then Y is obviously 412 by 2. So that's pretty standard. So the first epoch is running. When the first epoch finishes, I will start to see everything appearing on the right side of the panel. So there we go. First epoch completed. You can see the train and test accuracy, which is what I'm printing here, along with the test and validation loss. So as you can see here, the training is going very well. The loss both for train and validation is going down, and the accuracy is going up. And interestingly, we achieved that in very few epochs. You can also see here on the lower right part of the screen, you can see a CPU is maxed at 100%, so it means we don't have much extra room for the CPU. The RAM is running low because I have 4 GB. And here you have the list of processes. So because we're running 4 models, as you can see here, this one is the one that is running now. So 2 panels, 1 completed. The one that completed is this one, and this is the one that's running. And yeah, we'll probably need to wait a few more minutes. So now this one has finished, and the last model has started. So this finished. Now we have the 4 models. So let's see. I'm very happy about this small one with 39,000 parameters. It's quite small. The other ones are much bigger. So here we have the 4 models stacked together. As we can see, the initial was 7 million parameters, then strides equal to 8, 427, and strides equal to 2 plus extra convolution is 413,000 parameters. So these 2 are still very, very big, and probably not as small as we would ideally like. And this one in 39,000 parameters, I'm quite happy about this size. Kind of makes sense. Just to confirm, I mean, if we look in here, the accuracy seems quite good. We're over 80%. We probably could keep this string for some extra time, but yeah, I'm quite happy. If we look at the other one, so this has 427. Yeah, it seems okay. I mean, we're only training in 10 epochs, so if we left this for 100 epochs, obviously it would have been very similar to this one. Strides equal to 2. This is the baseline. Pretty solid. And strides equal to 2 plus convolutions. We probably need more epochs here. So overall, I really like this strides equal to 8 plus extra convolutions. It's a very small model. It trains very quickly. And to be absolutely fair with you, in 100 epochs, which trains quickly, we are getting a value accuracy of 91%, which is very, very high. Overall, I picked these strikes equal to 8 plus extra convolutions.